Good afternoon, everyone. My name is Barbara, and today I'm going to help teach you guys about the immune system. Now, the immune system is, of course, inside your body, which makes it very difficult to see or to study, but we certainly understand the effects of the immune system. Everyone knows what it's like to get sick. So today, with the immune system, rather than using drawings or computer renditions, I am going to be using everyday, common, household items to help demonstrate to you exactly how your immune system works and why it's super cool. So let's begin. Your immune system, we're going to look at it in 3 different levels. So first we're going to look at things exteriorly. Your skin, the outside of your body. We're going to look at things moving just inside your body. Specifically, we're going to look at organs and how they make and move your immune system. And then we're going to zoom in even closer and look at things on a cellular level. Teeny, tiny, really hard to see cellular level. With each of these phases, we're going to pull out the magnifying glass, and that's how you know we're moving from one step to the next step, to the next step. We're going to magnify and get closer each step we go today. So with your exterior part of your immune system, very simply put, your skin. We can all see our skin and touch our skin. We know that it is a solid, complete organ on the surface of our body. And your skin is the #1 first line of defense in your immune system. Things like mucus and snot also play a part in your skin. Specifically, if we look at a mask, kind of scary, but the reason that some people wear masks are to protect their eyes, their nose, and their mouth, which all happen to be openings into your body or breaks in the skin, which have wet, mucousy layers or snot to help catch pathogens. So what's a pathogen? A pathogen is something foreign that you don't want in your body. Examples of pathogen: fungus, bacteria, viruses. These are all things that if they get into your body, make you sick or cause you harm. So we'll mostly refer to them as pathogens, which kind of covers all of them. So, if your skin, first line of defense, fails, the second line of defense tends to be inflammation. The site of the wound or opening is going to start to swell and inflame. This is going to try to block out certain pathogens or viruses from getting into your body further. If they succeed in getting in and taking hold, that's where you're going to see #3, a fever induce. Fever has a lot of great ways of inhibiting the bacteria or the virus's replication and spreading, but also helps to mobilize your immune system, and specifically some of those T cells and B cells that we're going to talk about later. So, quick demonstration. If your skin gets a hole in it, now, I'm not willing to cut myself for the sake of this video, so I'm going to use a nylon to demonstrate skin, and voila, that's a knife. If you were to cut your skin, this allows for an opening inside of your body. Now, already there would be swelling involved, but what I'm going to use today to demonstrate a pathogen or a bacteria is glitter. A lot of people hate glitter. It tends to get everywhere and stick everything, so I think it makes a really great demonstration for a pathogen. If I sprinkle glitter onto the wound, you can see that some of it is getting through the hole and into my skin. So if the nylon is representing my skin, the glitter is now a pathogen inside my body. This is where your immune system kicks in. This is what I like to call go time. Now, on a side note, teachers, if you have elementary students and you're trying to teach your kids about germs, this is a great quick demonstration you can do. Glitter on the hands, rub it in, and have them go wash their little paws. If they come back to you and still have glitter stuck between their fingers, under their nail beds, then you know they haven't washed properly. So this is a great way to talk about microscopic germs and the importance of washing one's hands. And it's something fun that little kids can understand and everyone will hate because glitter does get everywhere. So once the pathogen's inside your body through that opening, we're going to pause there in our immune system because I want to magnify down from an exterior into our first level interior view. So we're going to set our pathogens aside for a second and just look at the organs inside your body that help create your immune system and help move and circulate your immune system around. So first and foremost are your bones. If you look at any large bone inside your body, hip bones, femurs, humerus bone, if you open them up, you're going to find that they're full of red bone marrow. This bone marrow happens to be the creation site of your immune system. B cells and T cells are created here. A lot are created even before we are born. However, your blood cells, your red blood marrow here, can help perpetuate and recreate B cells as your life goes on. So, first and foremost, your bones, red blood cells. Another important part is your thymus. Kind of an obscure gland in your body. So to make it a little more relevant, if this is your heart, your thymus sits right here, right in front of your heart and just north of it. I made it kind of bumpy because it's a gland and it looks kind of bumpy. So as a child, specifically as an infant, this thalamus gland actually covers up most of your heart. It's very large. Because as an infant, you need more immunity because you're being exposed to new pathogens. But as an adult, it shrinks. So as an adult, this is about proper ratio from heart to thalamus. It will continue to shrink, though, as you get older. Your thalamus starts with the letter T. This is where your T cells, created in your bone marrow, migrate to develop and mature. Your B cells, starts with B like bone, stay in the marrow until they're matured and then they're kicked out. But your T cells migrate to your thalamus very early on and mature here. Your spleen is also an important part of your immune system. Once B cells and T cells are matured and ready to go, they tend to hang out in the spleen. This is also, I've seen it referred to as a coffee shop. It's a place where they can hang out and exchange chemical information about different pathogens that they've connected with or exposed to while they were in your body. Spleen is also a holding center so that in the event of an infection, it can dump out massive amounts of white blood cells to help fight off whatever bacteria or pathogen your body might be having a problem with. Now, just for science sake, let's make that heart a little more realistic looking. Out of your heart, you have your arteries, and your arteries are the pathways that spread throughout your body, carrying blood, and they also help travel and pass along your immune system. Small green with a little gland on it, this is a lymph node. And the lines represent your lymphatic system. So you have these lines running all over your body. Lymph nodes throughout and the lymphatic system spreading. So here is the typical tracing path of a normal white blood cell. Being created in the bone marrow, once this B cell matures, it migrates its way over to the spleen. Once it's needed and some sort of infection has been detected in the body, it will kick out and travel to the lymph nodes where it is secreted into the red blood. Travels through arteries and it can jump out of the red blood cells, so the arteries, at any point in time to get to the surrounding tissue around. So it travels through the blood, hops out, can help fight an infection over in the tissue here. If it's no longer needed from the tissue, it makes its way to the lymphatic system, where it travels up the lymphatic system back to a lymph node. It can be stored in the lymph node, or it can continue to migrate all the way back to the spleen, where it can be stored as well. So not only does your immune system travel throughout your entire body, but it makes use of the circulatory system as well as the lymphatic system and the lymph nodes to get around. Because if you think about it, infection can strike anywhere in the body. So, these are your organs that are part of your immune system, creating, storing, maturing, and circulating all of your white blood cells around your body. We're going to magnify one more time. From the interior, let's now magnify all the way down to the cellular level. Teeny tiny little cells in your body. When we talk about white blood cells, we're talking about in your body right now, you have on the magnitude of 2 trillion white blood cells. So on a cellular level, when we're looking at white blood cells, we are looking at B cells, we are talking about T cells, we are talking about macrophages right there, and we are talking about natural killer cells. Note that they're all white in base color because they're all white blood cells. Each one serves a different purpose, so we're going to run you through an attack of a pathogen. So if that glitter, going back to cutting my nylon-esque skin, and the glitter making it into my body, here are the pathogens. Note the color. The color is important because there's so many different types of infections that you can get. Like I said, not only are we talking bacteria, fungus, and viral, there are just millions and trillions of different things. So I picked a specific color to represent a very specific pathogen inside my body. The first thing that's going to happen at the site of the wound, macrophages come in. A macrophage is a larger white blood cell that's rather amoeba-like in tendencies. It's got an opening, it's got these long amoeba arms that can help reach out and grab onto pathogens. So what the macrophage does that's so amazing, it is non-specific. When we talk cellular immune system, they like to make the distinction between a non-specific and a specific white blood cell. This is non-specific. It's all white. There's no particular color to it, meaning this guy can eat and consume any color, any type of pathogen in your body. I like to think of him as Pac-Man, and he just kind of goes through your system and noms up anything that's not supposed to be there. So, with these tendril arms, he's going to grab, he's going to ingest that pathogen, and then from the surface of his skin, he actually pushes through antigens, which are parts of the pathogen, to say, hey, I ate something foreign from the body, here's little pieces of it, and then he also calls out for the cavalry and calls out for help from the rest of the white blood cells to come help fight. So, antigen presenting white blood cell. Now right here, an antigen is part of a pathogen. This is what some pregnant women need to be concerned with. If you've ever heard of an Rh factor, positive or negative, and that has to do with your bloodstream. That has to do with your heart. So I happen to have an A negative blood, which means my body does not have that specific Rh factor or antigen. If you have positive, then you've got certain antigens in your blood. Doesn't hurt you, but if a negative mom has a positive baby, your body might actually try to attack the body of the growing infant because it sees those antigens and thinks, danger, danger, send in the white blood cells. So just as a side note, antigens are a factor that women, pregnant women, need to think about. So our macrophage has just ingested one of the invading pathogens. He's now presenting with antigens, which allows for things like B cells from the bone marrow, B, to come along, and they match. They have the same color, which means this is a specific immune cell that has been created for this specific pathogen. These Ys, by the way, are antibodies to this pathogen. These connect and realize this is the pathogen in the body, so your white blood, or your B cells, your white B cells, release their antibodies, which can then attach to the pathogens and help hold them in place and actually align them so that more macrophages can consume them and destroy them. Your B cells don't directly interact with the pathogens, but upon receiving the signal, they release their antibodies and they multiply. They multiply fast. And what you're going to get is you're going to get these plasma B cells that have no antigen blue lines, but they've got the right antibodies. So they're going to start kicking off their antibodies, which are going to go around and attach to more of the pathogens, holding them in place, marking them for destruction. This B cell, however, is going to retain his antibodies because he is going to become a memory cell or a B memory cell. So he is going to remember this specific pathogen and hold on to the right antibodies, so if a reinfection occurs, he is all set to swoop in and save the day and kill them all. This, my friends and family and folks, is why having your child receive the correct immunization at the correct ages is so important. You want to make sure that you've got antibodies in stock ready to go for any pathogen, rather than not and having to start all the way from ground zero of digesting and creating the correct antibodies. So this memory cell is why it's always good to receive vaccines and have your child immunized. Now, we still have some pathogens floating around. This is where your T cells come in. T cells, like B cells, are specific. So we see some receptors that happen to match our pathogens, and what this allows him to do is to recognize it as a pathogen and to actually start stabbing and lysing, which means poking holes in the exterior cell wall, which causes these guys to die. So he's able to connect on physically to the pathogen, lyse it, which allows excess fluid in, which actually creates it to burst. So lysing is what your T cell does. Now, lastly, perhaps some of that pathogen wandered into one of your actual body cells. So this was your healthy body cell, which now has been infected with the same blue lines that that pathogen had. That's where natural killer cells come in. They too, like a T cell, have these long tendrils, but you notice that there's no blue color on him whatsoever. So he is another non-specific. Doesn't matter the pathogen, he can come in and kill off that entire cell, which also includes the pathogen. So, natural killer cells, non-specific. They can kill any pathogen that infects any healthy cell in your body. Macrophages, when not presenting an antigen, are also non-specific. They can consume pathogens, which then leads to antigen presenting, which also sends out warning chemicals to your B cells, to your T cells, and if you've already seen that particular pathogen before, your memory B cells remember it, have stored the correct antibodies for it, and will increase your response time and decrease the amount of the infection or the length of the illness. Memory B cells can live in your body for decades, some an entire lifetime. So these are just some of the white blood cells that make up your immune system. I hope you guys had a great time with me today playing with all my fuzzy, puffy white blood cells. Remember, 2 trillion in your body at any given time. And I hope you guys have a great time. Post comments down below if you liked it, and have an amazing day. Till next time.